Oh. Oh my gosh. Thank you, SudokuPad. I'm an idiot. Oh. Well. How long have I been streaming? And I muted myself. When did I mute myself? Earlier this afternoon when I used OBS quickly to record something off my screen. And I didn't want audio. And at the time I was thinking, oh, that might be a problem. Well, let's start over. Welcome to Code Hangout number 198, where I'm going to look at analyzing the data for 24,000 puzzles that have compared against each other. And what I've done the last, I don't know, 5-10 minutes was looking up some existing code to calculate certain basic statistical stuff, such as median, means, averages, convert things to CSV data, and so on and so forth. And basically what I was just trying to explain is I've pulled out 24,000 puzzle grids, a little bit extra, split into sets of 1,000 each. So it's 1,000 times 81 characters in each of these files. And it's just the full-on, just the full-on 81 characters of a puzzle, right? Like solution sets. And they're mixed puzzles. They could be classics. They could be, what's the word? Variants, right? But it's basically a list of all puzzles in my database that has exactly 81 1 through 9 characters, with the caveat that these are Roman squares. So basically, they are following classic Sudoku rules, so no duplicate digits in rows and columns and so on. And it's just to test. Maybe later on expand the work to include more puzzles and other kinds of things. And I'm using an algorithm that Neil Calkin has devised, which is basically converting each puzzle into an 81 by 9 matrix of zeros and ones, where basically the 81 represents the 81 digits, and the 9 zeros or ones basically represent for each of the 9 symbols, 1 through 9, if that symbol is in that cell or not, right? So for these puzzles, there will always only be one. So if it's a 1, it'll be 1 and then 8 zeros. If it's a 2, it'll be a 0, a 1, and then 7 zeros, etc. And then basically I take these matrices for 2 puzzles, transpose one, multiply them together, and what it does is it basically lets me compare shapes and patterns of positions of digits irrespective of which digit it is. So it doesn't matter if the positions of the 1s match the positions of 3s in another puzzle, right? So it kind of ignores what the symbols are. It just says, are there symbol patterns that match symbol patterns, and how close do they match? And then basically I calculate this for all of those puzzles against each other. So every file that I compare against one of the other files is 1,000,000 comparisons, and I do that 625 times, right? So that's 625 million of these comparisons I've done. It took a while. That's kind of what I've been doing this week. I create a little parallel algorithm that'll run it across 10 cores and so on and so forth. And basically what each file now contains, and from each of these equations, and the actual equation itself is very simple. It's basically this, right? So here we're looping 1 through, a nested 1 through 9, 0 through 9, sorry, 0 through 8, 9 iterations of loops. And then for all symbols, 81 symbols, we take the corresponding digit on one and the other matrix, right? We multiply them together, get the sum of those, and that gets us a number for these. Basically, it gives us a 9 by 9 result matrix, but I don't actually store that result. What I do is I count the occurrences of each of the numbers, 0 through 9, where basically it means the number of pattern matches against that ordering of patterns. Anyway, that's one statistic I'm collecting, and the other one is I calculate a singular number, which is basically the sum of the squares, the square root of the sum of the squares. It's basically mean square error. And I kind of normalize this to a number between 0 and 100, because it's normally between 1 and 3, where 3 would be an identical puzzle and 1 would be a maximally different puzzle, which I don't think is actually possible. So there shouldn't be any zeros. There actually is 0, so I'll have to actually see what that looks like, because I was curious about that. So these are the counts of these occurrences of all the 625 results added together, right? And if we look at just one of these, each of these files basically has the 9 or the 10 counts in the first row, and then in the second row for each occur, like for each comparison value of that 0 to 1,000, it has a count of how many times that value occurred. So basically a histogram. Hey, Olima, how are you doing? But as you see, this is a sparse list. So not all 1,000 numbers are actually possible because it's a large floating point number and I normalize it to 1 through 1,000. So I don't actually know for sure that I'm not losing some here, but the final file that is all those files added together, which is, I believe, total results. The final file, if I take this, put it here, replace the spaces with a line break, right? So that basically shows us how many of these different numbers we have. So 273 across all of them, right? It is possible. Excellent. Enjoy. It is possible there could be more, but it's also possible there's just, because of the way floating point numbers work or because some mathematical aspect of how, also because of the rules of Sudoku, not every combination of shapes, of patterns, of digits is possible, right? Because, many of them would be not Latin squares, right? There is a modification of this algorithm that allows for non-Latin squares, where basically, where 1 is, 1, 2, 3, 1, 2, 3, like this, and where 9 is basically the inverse, like this, right? If I allow something like this, that actually would be, that could be a 1 or a 9, right? So we could represent something like this. And obviously we could have 2 9s in positions that are non-agreeable, right? One of the reasons I did this originally was because I was using a compression algorithm of mine that only works on Latin square grids. But actually I didn't use it on here. I just literally compressed them and decompressed them just to do this check, because the compression algorithm will break on non-Latin squares. But I could rerun this and see how many more puzzles. But I don't think it's significant. There isn't a huge number of puzzles that don't fulfill the Latin square rule. That, there'll be chaos constructions and potentially faulty grids, right? There'll be errors in the database and things like that. Okay, so that was a whirlwind, quicko introduction of what you've missed. What I'm looking into now is I want to look at these 9 numbers and I want to look at them individually. And I want to calculate things like standard deviations. Ciao, guys. Means, maxes, mins, max, not just for these, for the other data as well. Now here I found this weird spike on the 1,000, which is a little strange because that implies an exact match. But I don't know if this is maybe some sort of flaw in my code or if this is actually an artifact of the data, right? So what I want to do now is I want to do some of the statistical analysis across all the 625 files. So maybe there's one file that's just stands out where this is weird, or if there's no problems, it should imply they all are similar. The only selective pressure on which puzzles are in which of these files is really that I sorted the puzzle numerically, which means that if I look at the sets in A, if I look, let me see, well, where is it? Which one? So if I look at the sets in A, can I do this and do a replace of 81 characters with the actual, like this? Can I replace all? No. Oh, no. If I do this, can I do a replace all? Yee, okay. So as you can see, they all start with 1, 2, 3, 4, 5, 6, 7, 8, 9 because they're numerically sorted. I don't know if that affects similarity measures of any kind. So it could be that there is some change in the data from the early results to the latter results. We'll see. We'll see. It'll be interesting to know as well. I don't know if the numeric sorting has an effect on what kind of grids they are. I'm not sure they should. All right. So where was that file I just had opened? I think it popped over here. Okay. So here is some stuff that I did a while back that contains some basic algorithms for calculating sums, means, standard deviation stuff. They are not really optimized here. We have quantile buckets. Okay. Let's bring these over to here. So we have data helpers. There should be a tab. And then we'll do stats helpers. I'm just going to put all of these in there for now. Don't know how many of these are relevant. I might have to change them quite a bit. So sort ascendant, okay. Sort descendant. Let's do this. That makes sense. Quantile, sure. To buckets. Okay, because I was using this to generate ASCII graphs. Maybe we'll use it, maybe we won't. Let's keep these in our back pockets. Right. So, combine results. That's the function I was calling just now. And that was basically just looping through the individual files and calculating the histograms. So let's make a new function. We'll just say calc stats. Is that? Yeah. So we want to calculate stats, and we kind of want to do the same thing. We want to get the file names, and then for each of the file names, except we're currently gonna look only at the first one just to get started, right? And that gets us the histogram and the comparison data, right? So if I do this, and I'll output the file name, and then we can run this, I believe. Yeah. So and I'm going to kind of bounce back and forth between the console down here and later on looking at the data. So that calculates the first bit of, it doesn't calculate, it pulls it out of the file, right? So this is the sum of, it's not the count, no, it is the count. It's the number of times we encountered zeros, which I believe are no matches, right? And 8 will always be 0, because if 8 digits are in the same position, then all 9 must be in the same position. Like we cannot have 8, I don't know, that's just how it works out, right? But I left it in there because maybe a little bit of almost like a check digit to kind of make sure there's some real crazy insanity going on. Okay, so now we want to calculate. Now for these 9 numbers, I'm not sure if these values are super interesting, but I gotta remind myself. Oh, and I'm just realizing I'm cutting off the left side because the layout is designed for having this here. Okay. So these are designed to operate on arrays of numbers, right? So I can do, I should be able to do a bunch of these immediately. And if I just say, hey, let count walls equals histo, it should basically be able to do all of these things, right? All right, so we have 10 values. The total sum is that. The maximum value is this. The mean is that. The median is that. And the standard deviation is that. So I think max, mean, median, and standard deviation might actually make sense here. And maybe min might actually also make sense. And then what we can look at this at is across all of them. Actually, min will always be 0. We might want to exclude 0. If I do map dot filter v greater than 0, would that work? Yeah. So now, if I do this for every file, we should be able to see if they're all within a certain range, right? Or is there any standouts, right? And what I was planning to do is basically create a CSV file where we have the result set here, and then these values are as columns, and then we can load them all in and create like a bit of a chart. Because then we could say, okay, what's the standard deviation of the standard deviations, right? And then we can say, okay, is any of them, we're basically meta-analyzing the data. So we can see if any of the data sets or the results sets are significantly off the norm across all of them, right? So let's do that next. Let's make a little function here that calculates all of these and outputs them as a piece of JSON data, right? So we'll say const calc stats calc result stats. Let's rename that so we can use calc stats in here equals and we can just put in data like that, right? Or let's just do it this way. And we can say return a piece of JSON that is basically these. And it just has all these stats in there. And then maybe I can modify it and say, hey, basically only include these or exclude count or whatever, maybe pass in which ones to calculate for these, right? The bucket stuff is basically for histogram-like things, right? 1, 2, 2, 2, 2, 2. And like this doesn't have to be efficient. Like we're only doing this for a relatively small number of things. I think that's all we need to do, right? And then we do calc stats of histo. Now that should get us a little bit of JSON data. Calc stats. Let's just do it this way. All right, there we go. So we can now combine this as a file name, yada yada. Now the file names include that prefix thing, so we wanna kind of filter that, and we can actually include the original data as well. Does that? Yeah, I guess we'll just need column headers for that. So the file name we'll want to replace the folder thing, fn.match or fn.replace or slice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. Like if I do this, right, it'll just be, nope, 11. Result a8.txt, right? That'll get in the file name, right? So now we can say object.assign. Then we can just say file like this. And then we can put the stats in there. Right? And we'll need another one of these. We need that, and that. Right. Do I want to include this? Because if I do this, what do I get? I mean, I guess we could just put that in there as well. Right? And then we don't have this. And then we can basically do this for each one. It's annoying that this is kind of getting resorted, which I was hoping it wouldn't do. Can I get the file to be at the start? If I change this order, will it always be in this order? Yeah, that's weird. That is weird. Let me try something. Let obj equals this, right? And then obj object.assign obj this. Is there a way of keeping the order of the keys? So if I do it like this, the file stays at the top. But what if I do this? It doesn't. What if I do... object dot entries obj, turn it to an array, right? Object dot entries dot obj, do the same thing for histo, right? And then if I put the two together, like that, I should get an array with this order. And if I take that and I'll do object.from entries, does it resort? Does it resort? Yes. Well, that's annoying. Oh, wait, here. Oh, because it's still an array format. We also have object here. If I just output object here, skip these for a sec. We'll output that twice and we'll say obj 0 equals ABC. Is that messing it up? Yeah. Huh. Java. Okay, I'm wasting time, but object key order. Should it maintain key order? I think it did. For non-integer, while adds property order, it does not require for an object keys to string to order it or to like the foreign loops iterate according to numerator, which defines this method of O is called the following objects are taken. Return an iterated object whose next takes all the string related keys of numeral objects O. I mean, we could rename them. We could rename the keys. Right. Okay, let's do that actually. So if I do histo and histo map v and make that into or vi, and then turn that into an array element, histo I v. Like if I do that, right, I should be able to turn that back into an object. Object.from entries, and that should be compatible with keeping the key order. So if we go back to here, right? Yeah. So we have all the summations at the front, we have the data at the back. That's kind of what we wanted. All right, people, I don't know, people ignore the fact that I'm streaming. So let's see. Now that we can turn to a CSV using my little CSV function. So if I say CSV this, that should just straight up work. Oh my God, come on. So if I do this, yeah, it'll work on an array. So if I have a bunch of these, we'll do this. Right. And then a file with this in it, I should be able to put into into sheets, right? So let stats equals, we'll make an array. We'll do stats.push this, which will give us an array for, you know, let's test it with a couple. And then at the end, we should be able to output a CSV version of these stats. And that's it. Right. And even running it for all the files, this shouldn't really take, yeah, it doesn't take a significant amount of time. And then we can just put this into a file. Histo stats.csv. So if I do this, and then I do file, import, upload, his stats, I was supposed to be histo, and I'll say create new, insert new sheet, import data. And that should get us something like this. And I'm gonna go a little bigger on the screen here. So we have all the results across the left side, the file names, right? Then we have the counts. And let's do this. For some reason, it really bugs me when there are like extra columns and rows. No, what just happened? Okay, and the same with the rows. Row. Although this time we actually have a significant number of the 1,000 used. Rows. Okay, here we go. So we could draw the histograms against each other and see if there's any weird standouts, right? We have the sum. The sum should... Okay, because the last file is a different number of puzzles. I might have had to... I should have probably excluded that one. Because it'll skew... Well, it doesn't skew most things, potentially. Just min and max, right? Like min and max should be fairly similar. Like this one has a significant higher min. But maybe that's because it's the self-comparison, so there's a lot of... yeah. Also, I've realized because I didn't avoid comparing puzzles in both directions. So this is really double the data, and I might have to redo this calculation in half the time, thankfully, because I don't know if that messes with the actual data somehow. YouTube is struggling to play my music for some reason. I don't know why. Huh. Okay. Be careful, because it's happened to me several times now that I got locked out of my YouTube account while streaming, and I have no idea why. All right. And so far, I know this is all a bit dry, but I promise you we're getting somewhere. So let us look at... I almost want to exclude... I want to do it again in excluding the last file, just because it has a different number of items in it. So it's going to be just a pain in the butt, especially when I'm just looking for anomalies, right? When I'm anomaly hunting. So if I do this, and I say .slice -1, that should do the trick. No. If I say 0 -1, it should... the problem is it'll exclude the last result, but it won't exclude any of the results that include the Y file. Yeah, I want to exclude everything with Y in it, basically. So one from each of those. So it's quite a few, actually. All right, so we'll actually need to do filter fn dot or /y/test fn, not that, right? So if I do this, it should not have y in it, but it should also not have xy in it, and shouldn't have wy and all this stuff. Okay, so this we should be able to do. Let's do that again. Get rid of the old his stats. And we should be able to just re-import that. just by dragging that here, and then replace current sheet. Right? Again, delete these. And this should now no longer have these weird min-max. Yeah. And then whenever, it's interesting. So the min goes up whenever we have the self-comparison, because there are more matches. I mean, there's an exact match for sure, because obviously the puzzle gets matched against itself. But the other 999 puzzles aren't the same puzzlers, right? So I'm not sure why that's as much of a problem. But that's, you know, that's the sort of thing maybe I'm trying to figure out. Maybe. I don't know yet. Let's ignore the data over here for a sec. If I do this and I just throw this into a big chart, is that gonna be a problem because we have 600 or 5, or I don't know how many do we have? 577 minus the header row, 576 of these data sets now. We are actually trying to compare them individually. Like, they're not compared against, like, it doesn't make sense to compare the standard deviation versus the mean, etc. So what we actually want to do is we want to do a stacked chart, like a stacked bar chart, kind of like this, right? Where basically for each kind of thing, we see it for all the files. Is that what we want? Or we want the reverse of this? Let me think. The series is definitely these. So the x-axis has to be the file, right? But what happens here? So if I have something like mean here, can I just toggle this? Can I? Nope. Count standard deviation. So for example, if I wanted to just look at standard deviation. All right, so this doesn't. Hey, good morning, particle flag. Hey, CERN. I don't know how to pronounce that. So we're gonna do a few things because I'm not a data analyst, right? So we could either focus on one of the data points at a time to not confuse myself. And that's probably what I should be doing. Let's try that. All right, so if I say, we're gonna remove that, remove, and remove. So now we have only standard deviations, and now we could maybe do this. Maybe we can do... So basically, I want to know how much they differ from each other. And the error is relatively small. Or the difference is... Is there a way of highlighting the differences between values rather than the absolute numbers, right? So we kind of want to like this kind of thing, right? Plus, minus. Ooh, they go up. Wait, what? Oh, no, that's a summing thing. No, we don't want to sum them together. I thought this was like relative to the previous one, right? Going up and down and kind of like a candle chart. Oh, candle chart. Is that it? Prior says 5 columns, but only 2 provided. Am I misunderstanding how a candle chart works here? Apparently. Because this doesn't seem to... okay, well, if we now scale it and we'll say, okay, vertical axis, minimum value will be whatever. Boom, 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 boop, boom. All right, and maximum value is this plus 4 times 2, like this, 4 times 10, 4 times 100. Or 1,000. Oh, no, wait. The blue line is at the bottom, right? And now the blue line is where? It's at the bottom. Okay, we got to look at one of these data points. Standard deviation, something like this, right? So if I go here, put that in here, I'll say the minimum is this, but smaller. So we'll do 0, 0, 0, 0, 0, 0. And then max is that times 2. Because, am I not looking at standard deviation? No, that's standard deviation here. 12299.055. All right, forget it. Let's do vertical axis, logarithmic scale. Here we go. All right. Okay, so I'm guessing the spikes are the self comparisons. So we might need to explain. Although I still don't understand why they would stand out, because they should at most be one puzzle or two with like perfect scores that skew it. Other than that, the puzzles within the same data set, within the same 1,000 puzzles. CERN. All right, cool. They don't have anything else in common, right? So comparing the data set versus itself, well, it means that every puzzle has a match against itself. So that's, oh no, but I didn't exclude self comparisons. Because we ultimately do want to include them. We just don't want to over-represent them, right? And maybe that's what adds up to those self hits. Because with a self comparison, each puzzle finds itself 1,000 times, right? Because puzzle A or puzzle 0 or 1 compared to 1,000 puzzles, it's one self match. Puzzle 2 compared to 1,000 puzzles, it's again a self match. And this happens once for each puzzle. So we have 1,000 self matches, right? So oh my God, part of me thinks, do I need to rerun it? But I could rerun it on a smaller data set. But this is why we're looking at this, to see if we can clean up this data, right? Because the run took 10 minutes and was a bit of a pain in the butt to do. But, so what I did was here, it would basically just run the next set and process next sets, right? So here it would basically look at what results files there are and then do the next set run. Yeah, combinatorics 101. Okay. So get next sets did what? Get next sets basically looked at the solution files and said, and it basically just looped through them all. And it said if it exists, if it doesn't exist, that's the next set. Okay. Now that's a set combination. So we do kind of want to compare sets against themselves. But the trick comes when we're comparing the individual items, right? So compare sets. So that just, we're passing in 1,000 puzzles each. So it just says, okay, load up set 1A and set B, or set A twice. And what it does right now, it says, okay, we're going from 1 to 1,000 and 1 to 1,000 and doing that. So let us set up a little bit of a test thingy here. All right. So we'll do something like process set testing. All right. And yeah, this is just a little local script file, so I don't really... It does bother me that it's like this, but, you know, we'll get over it. So we'll basically just want to say, okay, what are the two sets? And then how do we compare them, right? So we'll say, for example, that set 1 equals A, and set 2 equals B, right? And then we'll have the result like this. I'll do something like this. Right. And if I run this now, it'll compare set A versus set B. It'll take about 10 seconds because that's how long it takes to do a million of these, right? And 5, 4, 3, 4. Yeah, here we go. And then it outputs these results, and those are turned into the files as before, right? Now, what is happening here is that every comparison happens at least twice. So let's, first of all, let's have a, let's look at a smaller number of sets. Okay, I'm gonna just clone this so I can mess with it and I don't have to worry about breaking something, because this is not in source in a repo. Weird look at it. Okay, sorry, Cern. What I'm doing is, for some work I'm doing with Project 9x9, and this is kind of, it'll be a useful tool for sorts of things. But basically, I'm looking at the 81-digit grids of puzzles from the SudokuPad database. So not just classic puzzles and not unsolved puzzles, but basically the solution grids, and only a subset of the puzzles. Only puzzles that have a solution of 81 numbers from 1 through 9. No gaps, no padding cells, nothing like that are true Latin squares, i.e. 1 through 9, each row, column, and box. So no chaos constructions, etc., right? So basically, I have just over 24,000 such grids from the database, and I'm basically comparing them against each other using an algorithm devised by missing a few cards, which is basically turning, I think I have a little illustrative animation I made a couple of weeks ago. I think, can I find it quickly? I think it was this one. Yeah, so basically we take the digits, we lay them out into 81 digits, and then each digit, oh, can I pause this? Is there a pause button? Yeah, nope, there's no pause button. There's no pause? Options. Is there no pause? Toolbar. No. Why toolbar? No. Is there no pause button for this? There must be a pause. Which... This is not my usual GIF player. One second. I recently, it was for some reason unset, and I set it to this, but this isn't the right one. Portable apps GIF player. I had a really nice GIF player. I want it back. Sorry, I hate it when my tools aren't tooling. GIF, portal apps GIF animation player. No, not screen to GIF. I want a tool that just lets me view animation viewer. JPEG view, no, GIF viewer portable. I'm not seeing it here. GIF, oh, that's GIF cam. Music video, is it? Graphics pictures. GIF. Animation. Animation. Nope. Maybe it's under file viewers or something. Utilities. GIF. Image. Viewer. No, maybe it's been removed. God damn it. Always the stuff that I like. Image viewers. XN view, maybe. Maybe? Was this one? No, definitely not this one. RFN view, fast diff image corners. JPEG view, but I remember it. Yeah, anyway. Sorry. Anyway. Oh my god, I got sidetracked. I hate when my tools don't work. Anyway, basically by multiplying these matrices together, we'll find similarities of the patterns of digits, right? So it doesn't care if 2s are replaced with 1s and vice versa, but if most of the 2s are in the same position as the 1s, it basically gets a high match, right? And does that for all the digits. And that way we're hoping to find puzzles that are very similar, or at least be able to confirm if a puzzle is very different or very similar. That's kind of the idea. Sort of, kind of, but the nice thing about it is that it doesn't care about which digit, right? So if you take if you take a puzzle, right, copy it, and then you're randomly flipping the digits, like swap the 1 and the 9, the 2 and the 5, or whatever, this algorithm will still see them as identical, as long as the relative positions of the digits don't change, right? And what I want to look at now is if this lets me say something in general about this population of puzzles, because what we're hoping to do is, like for example, one of the things I need to work on is a publishing mechanism. So I want a place where people can officially publish a puzzle at high quality that gets included in a discovery system, right? So search engines for puzzles, you know, a listing of puzzles, things like that, which I cannot do with the puzzles I have right now because I don't know which of the puzzles are actually in use. I don't know which puzzles are intended for public consumption because, you know, people use my site to show, to give puzzles to their Patreons or to their paying members, like secret puzzles. But there's nothing in my site, my SudokuPad doesn't know, right? Which so far hasn't been a problem because I don't have a discovery surface. I don't have a way of going to a puzzle if you don't have a link from somewhere else, right? But the moment I take people directly to puzzles, I personally kind of take responsibility. And I don't want to do this haphazardly, right? So I need a way of people to officially say this puzzle is okay to be shown to people, right? I want to have a page, sudokupad.app/random, where it just always shows you a random puzzle, right? And I want to be able to link to that at the end of a puzzle. And I want to have that list of random puzzles be curated, you know, curated in terms of these are not under construction, these are not secret puzzles, these are not broken puzzles, etc., right? So this algorithm will be one of the algorithms to check if a puzzle already exists or a puzzle like it. You know, I don't want people go in there and find a Festomathel from 3 years ago and then say, oh, this is Timmy's new fancy puzzle, right? Please publish it. So far, that hasn't been a problem because there's no profit motive. And that's the thing is, I don't actually know if it's not been a problem. It might already be happening and just nobody has noticed, right? So this algorithm hopefully will let me find out things about the puzzles in my database. Things like, are there puzzles that are really similar? Are there puzzles, is the same puzzle published under different author names? You know, things like that. So it's kind of a fundamental thing I need for the next steps of SudokuPad, right? Anyway, so, and what I did in the original analysis of the data, and sorry, my audio feels wrong. So if in fact, I think it's kind of, maybe I hit oh yeah, wait, why is this so high? How is this? I must have been kind of overloading the microphone. Maybe I was a bit loud. Yeah, the one thing the algorithm doesn't currently handle are certain other transformations, like rotating a puzzle or, you know, flipping it upside down, things like that, right? But thankfully, there are relatively few such transformations, so we can, once the algorithm is more, once we know the algorithm is a good algorithm, we potentially could just run it 5 or 6 times for all the, it took only 10 minutes to do it for all these puzzles, and I think I did twice the work I needed to. So I could potentially run the algorithm 8 times on all the puzzles, right? And ultimately, this is all puzzle against all puzzles. But when you're just running one puzzle against the whole database, it's actually not a problem at all. Yeah, exactly. The nice thing is, a lot of the, there will be other things involved in it. So one other thing I'm working on is visual comparison, right? Making a screenshot of the puzzle and saying, do they look similar, right? And the nice thing there is I can do things like ignoring the colors, and then other things we'll do is look at the puzzles themselves. Like there's no point comparing a Katadoku pillar to a 4x4, right? Things like that. And in the future, hopefully also things like, hey, if one puzzle has killer cages and the other puzzle has Kropki dots, they're probably not the same puzzle, right? Well, yeah, you wouldn't want to do that because then your database gets huge. There are millions of transformed versions of a puzzle, basically. Yeah, well, that's the thing, right? That's something I'm curious about. Like, I want to see, for example, if we suddenly find that every puzzle has thousands of puzzles that are basically the same, but they're all completely different puzzles when you look at them, then this algorithm won't work, right? If this algorithm finds 1 or 2 puzzles that it marks as very similar, and we look at them and we realize, oh, those are basically the same puzzle, then maybe this algorithm will work. And that's part of the reason why I'm doing this, where I'm running it across all of the puzzles against each other to see what the state of the current database is like, right? Yeah, I mean, I understand what you're saying. Okay, so right now, for example, because I'm comparing each puzzle against each, every puzzle gets compared twice, right? Because like I compare A versus A, then A versus B, then B versus A. So we have done A, B twice in both directions, right? And the self comparisons kind of skew the data as well, right? And these spikes are basically whenever I compare a file against itself, where there's a lot of self comparisons, right? There'll be a million or 1,000 self comparisons, right? And then we get these spikes on those numbers, right? So what I'm doing now is I want to see, okay, first of all, remove the duplication. Second of all, don't compare puzzles against themselves, right? So now we won't get a clean million comparisons out of 1,000 puzzles anymore, right? So right now, instead of outputting the results, I actually just want to output... so we want to output the histogram first, which is the first row. We can just do it like this. And then the second row, I'm actually more concerned about the length. So if I do this, and then now I run it, actually let me, because right now it runs it by 1,000. So let me change this to 100. Just because the million comparisons currently take about just under 10 seconds. And I don't want to wait that long, right? So for example, we get... it doesn't tell me actually how many comparisons we're doing. How do I find that out? I think the sum of these would be the number of comparisons, right? So if I'll do, say, object.values of res1, and then the sum of those, right? And if I say sum, that should tell me how many comparisons. Yeah. So right now, if I compare 100 versus 100 puzzles, that's exactly 10,000 comparisons. But we don't want to compare where I and J are the same, right? And we don't want to compare, you know, I equals 0, J equals 1 with I equals 1, J equals 0, right? So really, J here should always start at I, right? So if I is 0, actually at I plus 1, and that way we will not compare it against itself. So if we do this, and we output these, and let's go down to just 10, and we can do A, I, and J. And if I do this now, right? So we now see we compare 0 to 1. So a 0 gets compared to 1 through 9, but not to 0 as it was before. Now 1 doesn't get compared to 1, and it doesn't get compared to 0 because it's already been compared. So 1 only gets compared to 2 through 9, and I hope you guys can see it. And then 8 gets compared to 9, but 9 never gets compared to anything else because it's already been compared to all of them. And this should compare every puzzle once against every other puzzle and never against itself. And now instead of having, you know, 100, we only have 45. So it's like half the number of comparisons we have to do. And if we do, instead of 10,000, we get 4,950. So we get half because we're not doing both directions. And then we'll remove the self comparison. So we're removing another, let's see, we're removing another 100 comparisons, but only half of those. I feel like I'm missing something here. If I go down to just 2, right? And we'll do I, J. Now do this, right? So we have 2 puzzles. Oh, yeah, okay. So the problem here is this presumes self-comparison. Right. While if we're comparing 2 different sets against each other, then we have a problem. Okay, so we have to kind of be careful here. Yeah, triangular comparison, that's it. Same puzzle. Yeah, Olima, that's exactly like I want, not just this, I also want to have multiple puzzles be like multiple puzzles in the database can actually represent one puzzle, right? So I want puzzles, let's say, for example, James likes to make his puzzles with and without colors, or like a hard and a smaller version. Like all these puzzles should be able to be grouped together, right? So you should be able to have a puzzle set that represents one puzzle, but it could be different languages. It could be an easier version, a harder version, you know, that kind of stuff, right? Half of the comparisons are in the first half of the group you eliminated. All right, let me think about, because I think this only applies to self-comparisons. I feel like my brain is being an annoying guy, right? Oh, we have spreadsheets, right? We can do a spreadsheet. So let's say we have puzzle A, B, and C, and then we have X, Y, and Z, right? And this, we want to compare X with A, B, and C, Y with A, B, and C with A, B, and C, right? So we want 9 comparisons. So for one counter, we go A, and then X, Y, Z. So, or let's say, let's say this is our first counter, this is our second counter, right? So first comparisons would be 1, then 2, then 3, then 4, then 5, then 6, then 7, 4, 7, 8, 7, 8, 9. So I'm guessing when I'm comparing 2 independent files, there is, it feels to me now like I'm wrong. Am I doing, so the double comparisons is only a problem when we're comparing the same file against itself. So that's why in this chart we have these spikes, because that's the files where the self comparisons happen. In files where we don't do self-comparisons, we have 2 independent sets of 1,000 puzzles. This isn't a problem at all. Basically, because I've broken down the processing of the results into steps, right? So I broke down the total number of puzzles into 25 separate files, right? So I took, you know, ignore the fractional one. Let's say we have 24,000 puzzles. Each file contains 1,000 puzzles, right? So now I can do a comparison of one of these files versus another file. But basically what I did originally is I compared each file against each other file, including itself, because obviously itself contains 1,000 different puzzles, and I want to compare those 1,000 puzzles against each other as well, right? So I think when the files are different and there's no puzzle overlap, we need to still do all of the comparisons, right? So this is really only a case when the puzzles are different. Now the question is, am I better off making a separate algorithm, or is it good enough for me to I think I actually do want to do 2 separate algorithms here, because there's a bunch of other things that are happening here twice, like converting the puzzles to matrices, the puzzle data into matrices. Because for 2 separate sets, I have to do it by twice, right? And for, you know, anyway, so let's compare compare sets, same, right? We'll just do this. So what happens here is, pattern counts. Yeah, I think we need to do this results processing as well. But basically, we do this. We only load 1 set, right? And we only do 1 conversion. And then we'll do the loop. Solve to matrix, yeah. So then we do the loop. And this is now where we want to do the algorithm I just worked on, right? Where we avoid self comparisons. So if I do this again with A, B, C, and let's make these a bit smaller, right? And we'll do this, right? And now if I compare these with A, holy moly, all right. And we're now comparing these against A, B, and C, right? So we don't want to, we'll skip this. This will be our first comparison, second comparison. BA we skip, BB we skip, BC is our third comparison, and that's it, right? Now, why does that get us minus 50 on 100 by 100? Because it was 4,950, right? Like, the diagonal on the 100 by 100 should be 100 items. That's what confused me before, because we did 100 by 100, which was 10,000 comparisons. Half of it would be... Wait a second, this is not half, right? And that's kind of where I think where I get confused. If I include the diagonal, or if I exclude the diagonal, these two aren't half. This is 6 and 6. These are a third. And if it's 4, it'll be 4. And then 1, 2, 3. Let me do this for a sec. So 1, 2, 3, 4, 5. 1 sec. 6, right? So now the diagonal is 4, but here we have 6. So 6 plus 6 is 12, plus 4 is 16. Oh, because it's squared. So this is 4 by 4. So this is a quarter, and then these two are half of the remainder. So if this is a quarter, these both are 0.375, right? So 16 multiplied by 0.75 divided by 2 is 0.375, right? That's basically what this count represents. Anyway, I'm gonna make myself crazy here. Puzzles could be hashed. Yeah, no, they could be, but the algorithm is fast enough. It doesn't really matter. Hey, CERN, thanks for stopping by. Appreciate it. 50 of the 100 is in the half that you're limited. Yeah. All right. So that means, but I guess I just need to recalculate the self-comparison result sets. The other ones don't matter. Or not, they don't matter, but the data is good. So I just need to compare set same, right? So we'll do that. We still have to transpose the puzzle. But now I plus 1, right? And MA, MB, comparison, result push. Is there something here that's external? So we'll do pattern counts, histogram, res, pattern counts. Where did the pattern counts come from? Okay, pattern counts. All right, compare sets. Create histo, right? And we're just going to pass in the results. We'll just rename it data. And it'll just be this. So it'll be data sort, data length, histo, right? And then here we just say const histo equals great restore res. And that includes the sort. Yes. All right. And then we basically do the same thing over here. Right. And then here we'll just say if set1 equals set2, return compare set same set1. So if I do this, now this will be a slow comparison because I'm doing the full 10, the full 1,000. Let's, okay, that's weird. M2 is not defined. Yes, M1 dot length. Okay, 3. Because it should be half the amount of time. All right. So if I time this, it should be around 4 and a bit seconds. 4.5 seconds. Cool. Now, the other problem is because it's fewer comparisons, we can't directly compare those files statistics against the others, right? Because the numbers won't... I mean, we can compare things like standard deviation, just not total counts and things like that. Yeah. Okay, so we have compare same sets. The other algorithm basically stays the same. I think. I didn't break it, right? We pulled this out. I mean, there's a bunch of stuff we can probably simplify, but this is fine. This bugs me. This way of writing it bugs me. In fact, these can all be constants, right? So we can just do this. And if I do a comparison of A versus B, we're gonna wait the 9 seconds or something to do the full thing. Yeah, it's the 9 seconds. One thing I don't fully understand is why is res 0 like that? Let's do the AA again. It's a bit faster, basically. So let's do that one again. So res. Oh, because that was, wait, what? My brain didn't see that. Okay. So this is the sum. Okay, that's the number of comparisons I've done. Oh yeah, okay, so it's 499,500. So we're missing 500, of which wait, I still don't understand. Off the so we have 1,000 puzzles. Half of them. Okay, because we're halving everything. Yeah, all right, I think I got it now. And the music stopped, even though it's not supposed to stop. Oh, yeah, I don't know. YouTube just asked me, are you still there? Oh yeah, no, I got signed out. I got signed out of the account that I'm streaming with. This happens way too often. Why would I get signed out of YouTube while streaming on YouTube? It doesn't make sense. I'm literally there looking at the browser. It's so dumb. Let's see if the stream is still running. Warning, stream's current bitrate is lower than recommended. Yeah, now I'm getting something is wrong. It crashes and now like I get like an error on the side off. Great job, YouTube. Okay. Let me know if anything broke in the stream. I mean, Twitch is happy. Everything looks great. Bitrate looks great. I don't know why YouTube is suddenly complaining. Stream's bitrate, 2,000 is lower than the recommended. What is the 68,000? I don't know why the bitrate is low, actually. Why is it 2,750? 1 second. That feels like it should be much higher. Output. Why is it 2,500 kilobits per second? I'm gonna have to look into that. Yeah. All right. That's good. Okay. So what we gotta do now is, I guess we gotta rerun the samey files. So combine results, process, next set, load results. So the combined results we also need to redo. So I think what we can do is, instead of doing the get next sets here, we can probably just calculate straight up the same things, right? So we can just go for one of these, and then we can just say console.log n to li like that. That should get us the set numbers, A through Y. And then for each of these, we can do the set comparison. And the set is just I. And then the result needs to get output into a results file, which looks something like this. The data gets compared like that, and then output like that. Right. Let's test it with 1 quickly and without outputting. That should format the data according to what it's supposed to be in the file. Sol sets set 0. Oh. All right. RST59 UFB here. I don't even know what that means. I feel like I don't know the thing. I don't know the thing. Oh. Ham radio reference? All foobar? I don't know. All right. Do I want to run this right now? It'll be 25 times 10 seconds. Not really. Not really. I'll run this some other time. So what we're going to do is the stats comparison, we're going to exclude the same files. So, file names filter. All right, I'm going to do this, and then I'm going to do this. I'm going to do this. Because that excludes all the ones that have Y in them, because that was the incomplete one. And then we want to exclude the samey ones, which regular expression, look behind, same. My god. Regex match same character. So something like that, huh? So we should be able to match character from A through Z, an underscore, and I think we have an underscore on either a leading underscore as well. 2, 0. Match equals the same character. Works for any 2 or more repeated symbols in a string. We want to do this. And if I do the reverse filter and then return, that should get us all the file names that we are going to filter out, right? Which is going to work. Calc result stats. If I do this, empty list. If I do this, we get these. What am I doing wrong here? If I do this, A, B, B, C, C, yeah, and if I do this, 452. So that should exclude all of those. And then if I do this, we get that. And if I do this, histo, what did we call it before? Histo stats. All right. And now we go back to here. And I'll do file, import, load, histo stats, replace current sheet. And I do this. Ah, now those crazy spikes disappeared. Now we still have some spikes, but they're not that intense anymore. Let's have a bit of a looky-loo. Looky, because... Can I resize this? Because this spike, for example, CA, so ABCA. So here it says the standard deviation is significantly different from the others. Oh, and I'd love for them to let us put these into the non-scrolling part. So it doesn't look too crazy. There's still a few standout ones. What's this one? AC. ABAC. All right. Well, standard deviation seems to be similar now. Can we... What else could be affected by this? Min-max, probably some. So if I go from this, I say add series, max, remove standard deviation. Max is also fairly tame, I suppose. Why don't I have a vertical axis? Show column one as label. Why do we not have a x-axis? Legend, vertical axes, show axis line, chart style, chart axes, horizontal axis title, vertical axis title, STD, no, max. So if I change that, I add this. Oh, it's a separate... Oh, I'm an idiot. It's a series, not a freaking... God damn it. Sorry, ultra-fine business. I'm getting hot. My brain is working and it makes so much heat that my body gets hot. So, what other number of these numbers, statistically speaking, could let us know... Oh, if I only had access to a mathematician that is supposed to be helping me. Median, maybe? Let's add median. Yeah, I guess the label doesn't make sense, actually. What is this number here? Okay. So, again, these all look, there's a couple of spiky ones, right? So what I actually should do now is I should probably recalculate the totals, excluding the self-comparison files. Hey, Olima, that's off duty. Well, I don't wanna drag you back into service. So this is calculating the stats, but I had a combined results one here. And if I filter out these from the combined results, and let's see, combined results. I am making a, oh yeah, because it's a constant probably. Wait, that's the wrong thing. There should be a let. What? Combined results doesn't output anything. Okay. Here we go. I think that's the same format. So if I do this, and I think the totals file is this. Yeah. Actually, let me see if I can just convert it to the same format as the CSV data, so I don't have to manually push it around. So we kind of want this, right? So instead of file, we want it to be total. So let's create a little object here. We'll say file is called total, right? And then these, so total, how did we do the comparison there? We did this, right? Unexpected item, token. If I do this, install. Okay. So that should be the one for the totals. And then we do want to do the stats as well. Right, something like that. So that'll get us a count, some thing, yada, 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 right? And then if I do this in my CSV function, you get that as CSV data or not. Oh yeah, because it needs to be an array, right? But it'll be just the one row. Coo. And then we can actually just prefix that. Okay, 1 second. Let me turn this into a thing that outputs this stuff. So this is loads results file, histocomps, load results file. Combine results. So if I say combine results and then I return the same thing as what these return, so histocomps. So we wanna output this first, histototal, and then comps total. Those should be the same format as the individual ones, right? So if I then say return these, like in an array. Oh my god, I feel like I'm breaking so many rules in terms of terminology and labeling and all this stuff. Anyway, so now if I go back to calc result stats, right? And then here I can get combine results and do a totals. Let totals equals yada yada, right? Combine results. Wait, combine results. Boom. All right. So that's totals. And what we can do is, if I push in the files here, so what if we say something like this? If we say stats.push totals and then these, and we do that, and we'll just do something like this. And we're just control the log stats, return. So that should get us one row with 3 items, totals, these numbers, and these numbers, right? And then we'll do the same thing over here. So instead of doing all the conversion here, we'll now push our file name as part of this little array. Oop. This thing. Then we'll push calc stats. Do we do the conversion here already? Yes. So we actually do want to do calc stats as our second item, and then the results as the third item, and then we don't do the conversion here. So we'll do the same thing here. Calc stats, second item, and histogram, third item. We'll do that. And now we output this down here. We'll have a bunch of these in there. Let's just do 2. This is not defined. Calc stats. Calc stats. Yeah, no, we don't actually need to do this at all. We'll just do this over here. We don't even do calc stats here at all. We'll just do that. Boom. Right? Except combine results here. Comps total is an object. What? Excuse me. What? So we have totals, array object, and then we have file array. So comps here comes back as an array. So load results file does what exactly? Comps is it's just an array. Why is it not an object? I don't know. Why is combined results an object? I don't know. Oh, because that's loading it from the file and then turning it an array. Okay. To convert this to this syntax, we just... One sec. If I do this, right, should it show me? So we just do object.entries basically. Object.entries. That. And that should be the first row, which would represent the totals. And then these are now looking the same, except this one is converted to numbers while that one isn't. All right. Dot map. NAB. Parse int a b. If I do this, right? Now they should be the same format. Okay, and now I can just do that. And then down here, we want to basically map them to this. So we'll do this map where we have label or name in the first and histo in the second. And we're going to turn that into an object that has these things, right? So it's going to be this, where we'll just have name, and then calc stats histo, and then this, like that. That. If I do this, we need an extra dot here. And now we should have something that's CSV-able. And we have the totals in the first row, and then ABAC. Now if I do this as CSV data, it'll look like this. Oh, we'll do stats equals, we'll do the conversion here. Yes, now we're talking, right? And the name is _3. Oh no, it's wrapping around, right? Totals, results AB, yeah. And we can probably do this. Slice 11. Name 11. If I do this 11, it starts from 11. So we want to do 8 from there. Except we want to do 21. Result AV. Okay, we don't need the doc.txt. Okay. And now we can get rid of that. And now we can do this and pipe it into our histo stats.csv file, right? And imported for the 5th time, I believe. Sorry, this is going a bit slow. I'm not a data analyst, so I kind of do things from scratch every time. Replace current sheet, import data. Because now we have totals in the first row, and we can always compare against totals, except, that's annoying. Except the series right now includes the totals. All right, so I'm misunderstanding things here because standard deviation. Because I thought standard deviation shouldn't be. It should be irrespective of the number of items, but the number of items is just the 10, right? Because we're just summing them up. We're not averaging them, right? So probably instead of summing up for the totals, we should average them. So does it make sense to count them up? The totals, if we divide them by 24, then they should represent... Yeah, because basically we have to scale, the totals are getting scaled because we're just summing up things, and the statistical analysis doesn't work that way. Freigeist in German. Free spirit. Freigeist, yeah. Okay, so basically what's happening is because we're summing up items of counts, and we always sum up counts in buckets of 9, the number of buckets doesn't change. So when I'm starting to do things like calculating standard deviation, it doesn't actually do the right thing. So I think standard deviation here isn't useful. And none of these actually are useful, right? Because I should be looking at the counts of 1. Like I should be looking at these relative to each other, independently of the others, not the sum of all of them together, right? And this, and I should probably get the average first, right? So these are always representing 1,000 comparisons or whatever, right? Because we're excluding the same comparisons. So we should divide these by 1,000, and then we should divide these by 24,000. This is just the sum of all of them, right? And then we can get the deviation between this one and that one, I suppose. And then in fact, instead of doing a chart then, we might be better off. All right, let's do it with the ones for now. So if I say, we do a column here, right? And we'll say this one is equal to this one divided by 1,000, right? We want to autofill that. And then this one is equal to this one divided by 1,000,000. Like that. Does that make sense? And this should be the sum of these. So if I select this, 1.1204, 104. Okay, why is it the average of this divided by million? Not divided by million, I'm an idiot. Divided by 24 times 1,000. Or instead of dividing all these by 1,000, I'm an idiot. Don't actually need to do that. We just divide that by 24. So then they're not really totals, they're averages. No, but not, god damn it. So this is supposed to be the sum of these. Oh, it's not 24, there's, Jesus Christ. All right, so then in that case, the total isn't really useful at all. The total is really just an average. Yeah, so comparing it to the totals doesn't make sense. I'm just realizing. Because we're not looking at the original individualized data. We're looking at summaries of summaries, basically. So having the totals in here isn't going to tell us anything. Because this is not really the standard deviation of all the data. It's really just the standard deviations added together, which isn't anything. God damn it. All right. That was a waste of time. I conclude. All right. Well, I guess it's not all lost because I found why we had a spike over here. So it might make sense now to also do this again. To do this again with those exclusions, right? And combine results, we'll get that. So if I do this, for example, right, that's just the combined results. Shit, I just overwrote the histostats one. Didn't mean to do that. Now, if we want to look at these, that'll get us this chart. Right. Okay. So we'll just do something like histo comps. What is that? Coms dot map AB. I'm just gonna create the data I need to build the JSON now quickly. So A is, we basically want comparison and count. So comparison A, count B, and CSV that shit. All right, is that gonna do that? What the heck? Something's wrong. The frick? Oh, because B is the counter here, not... God damn it. All right. If we do this, it should look like that. And now we should be able to get CSV data out of it. This is why people use Python for this sort of thing. Okay. And if I pipe that into coms totals.csv, right? I should be able to just replace this, but I'm gonna do it into a new sheet first, just so I don't do something to myself that I would be unhappy with later. Append, insert new sheet, boom. So that should basically be this list. No, this is also wrong. Comparison, count. What am I messing up here? Zero, 5, 10. Yeah, this isn't right, is it? This isn't right at all. We have 552 files. Comps, not combs. Comps, comparisons, comps. Comps total, ADX. Did I just hear? Hello? I feel like I heard the sound of somebody putting a glass down. But there's nobody here. Okay. That's... Oh. Hey there. Hey, I literally just said I heard the sound of somebody putting a glass down, and I looked around, there's nobody. You put a wine bottle on the tiles outside the door. Hey, Poochie. Hey, Toby. Toby. Oh, you don't like it when I'm on the stream, eh, when you come home. You walked already?
Yeah.
Alright. Alright, I'm gonna wind it up soon-ish, because I'm getting tired and I'm speaking nonsense. Yeah. Okay, so comparisons. Why are these not looking right? I'm still not sure. Okay, this looks good. Same error here. Okay, here we go. Now, we weren't using that before, so because I was hoping, oh, maybe that explains why things before were rubbish. No, because we weren't doing this before. So the rubbish before was just independent rubbish. All right, just a few little errors here and there. Okay, and now we can put it into that file. And now we can re-import that file once again. And this time we replace the sheet. Replace current sheet. And now these numbers should basically be similar to these numbers. Let's just do that. Bring them over there. They should be fairly similar. But there'll be a few missing because we removed all the self comparisons. Because we haven't done the recalculation of the self comparison file. Okay. So I guess it does do this. It does make sense to take these, just delete these and overwrite these, and then delete these. Now, if I look at this, and we still have a spike at the end. A spike, yes, but something super insane crazy, not exactly. Is that still the correct data? Comparison versus counts. Okay. Now I feel like I should have kept the other one because I would have been good to see the change. So we still have that spike to 6,000 at the end. So that implies there's still a whole bunch of matches. But what is interesting is that there's more exact matches than near matches. And that, in a way, makes sense. Because duplicates in the database is a given because of people, making mistakes, making changes, and creating the same puzzle multiple times. But near matches could either, is much rarer because that's either, accidental or, puzzles getting tweaked just a little bit, right? So I think that kind of makes sense. So having a peek at the exact matches. This peek, on the other hand, for example, is interesting. Like 556. So it would be interesting to see, okay, what does this mean? So this is likely some kind of specific transformation where it results in this particular comparison number. Maybe a puzzle rotation, maybe a swapping of rows or columns, or something that happens to a significant number of puzzles, right? And like all of these spikes are probably, considering how smooth the curve is over here, these spikes are all worth checking out. And exact non-matches I'm also very interested in. Especially, I'm interested in how many different types of these there are. Because I wasn't sure if that was even possible. Like a 100% mismatch. But it's actually fairly common. We have these spikes here, right? So there's a couple of spikes that are worth... Normally I would say, oh, this is within reason. But considering how smooth the graph is in this area, right? And the fact that we have this peak here in the smooth... And Neil was saying it's very likely to become a skewed bell curve, right? Not a skewed towards some number. But now it'll tell us, okay, because before we were sort of guessing at which values we were expecting certain kinds of properties to occur, right? But the reality is now we can say, yeah, sorry, I'm just kind of jumping all over the place. Because we are not, this scale is not homogeneous on the left side. So we don't know, like that might not really be a spike, right? Because, there might be a lot of missing numbers. There's 60 missing numbers just above it. While here, maybe the numbers are closer together. So it would be interesting if the the bottom scale is if there's a way of stretching it out. In other words, treat these as numbers, not as or treat them as values, not as labels. So treat labels as text. No. Ah! Now we're cooking. Okay. So that's the real look of this. Fair mode. No. Is this what we want? Do we want this kind of column style? Count versus comparison. Or do we want something like combo chart? Column chart? Why is it like this suddenly? Oh, because it's not logarithmic now. Okay. Yeah. I was hoping it would actually be combo chart. What's the difference here? If I do this, and this. Line chart, area chart. What if I do this? Log scale. Ah. It doesn't, it's not, the area is not a true representation though. So we probably want to stick just to a pure column chart, just to ensure that we know exactly what we're looking at. Cool. All right. I wish it could make them wider, but it doesn't actually work that way, does it? So this is actually the real chart. We do want to get rid of the left line. So I don't know if there's a tall blue line here. I don't think there is. Grid lines and ticks. We probably want to get rid of major grid lines. We do want to have these, but not for the horizontal axis, right? Yeah, okay, that makes sense. Because the exact numbers here don't matter as much. Or they matter, but not the rough numbers. While vertically, yeah, it'll give us an idea of the counts, right? So now we can look, I can start investigating these individual spikes. There's a spike down here, but it's not at 0. Can I just hover over this line? I wish it would let me find the value here. Is this at 0? Because, oh, it must be at 0. Okay. Is there something we can get in terms of error bars? Yes. Ah, but the error bars aren't really helping, right? It only helps if we have multiple data values. Can we get... No, trend line is not really useful either. Well, if we do a moving average... No, it's not going to help us, right? Basically, I want to say, hey, how far from where it's... Like, one thing we could say is if we have a trend line that matches our curve here. I do 6. No. Isn't there one for bell curves? I remember looking into that. Yeah, no. Basically calculating what the shape, what the property of this bell curve is, right? Because then we could say what the theoretical bell curve is with these properties that has a center here, etc. And then it would tell us how off these values are relative to where they should be, right? Things definitely get noisier down here, but that's because there's fewer samples in this. Yeah. So the last thing I need now is an equation that tells us exactly where along this chart we can be more certain within a certain, what's the word? Confidence level, basically, that a puzzle is similar versus not similar, right? Like in this range, there's a lot of puzzles. So obviously anything in this range isn't similar, right? One last thing I can do is figure out what the original number was, right? So this should be this divided by 1000. No, divided by 500. No, sorry. This needs to become a value between 0 and 2. So we divide by 500, and then we're adding 1. Right? And then that should range from 1 to 3. Right? And then if I go back to here, I can say... We'll change this to A. Boom. And now we've scaled it to our original numbers. The formula equivalent. Whoa! No. No. Oh, what the heck? Why did you do that? There we go. So now we can say, at around 2.5, yada yada. And that's I think exactly what Neil was looking for. Can I not scale it this way? There we go. Cool. All right, I think I was going to call it here. My brain is fried. This is complex stuff. There's a little bit more to do, and I need to clean this up so I can generate these files, regenerate them easily. And now I need to recreate the files that I'm excluding right now. Again, that'll be out of 5, it'll be like an extra 50 files that are half as big as the others. So it's not like, or half as many comparisons as the others. So it's not a huge, significant amount of data. We'll see. I think down here, this isn't filling in because of rounding errors, basically. There's like there aren't any values in this area, I believe. But I might be wrong. Hey, Hananessa Kari, sorry, you're just catching the end of the stream. And Olima, thanks for hanging out. I really appreciate it. That's it for today. It was a weird one, all numbers and stuff, but sometimes you got to do the math, right? That's all part of it. I wish I had a better way of making this exciting and visual and a clear way of explaining it, but I don't understand it that well myself just yet, so I'm still figuring it out. And once we figure it out, I hope I can do something to visualize it better, to, animate it a little and make it a little bit interesting and exciting. Yeah, I definitely I'm planning to plan something special. I haven't planned it yet. Oh, hey. You would have been handy earlier. Yeah, I definitely want to do something special. I don't know if I would just want to do what I did last time, basically a tour of the thing or something completely different. Lately, there've been a lot of people who's like, oh, is the app even still being supported? And that's all I do. But maybe I can talk about Project 9x9, say why, I'm spending quite a bit of time on this stuff because the university is supporting me and this is something they value. And I think that's something useful to me as well. So I don't know if I want to do what I did last time, where I did a 3.5 hour tour of the app, or if I want to do a very specific strategic, hey, this is what's going on. But it'll be a bit of a state of the union of SudokuPad kind of thing, right? Where's SudokuPad? What is it doing? What are the plans? And it'll be a good place to point people to that are wondering what's going on. Why hasn't the app being updated? There haven't been as many features being added more recently because the app is getting a little bit big and it's kind of creaking a little bit under its own weight. So there's a bunch of work I need to do just to keep the app running at the moment. There's some work I want to do to make the app more reliable. The server has been down twice in recent weeks. That's something that shouldn't happen. Luckily, so far, I've avoided data loss, but a lot of the systems in place are we're all prototypes and quick, and later on I'll do it properly, you know, no automated backups, it's all manual. So there's a lot of stuff like that. And when I work on these things, the app doesn't get a new feature, it doesn't get any new buttons, it doesn't get any new crazy puzzle ideas, you know. But maybe I can talk a little bit about that stuff. But I don't want to make it boring and dry, you know. I want these special episodes to be interesting, exciting. So if I do that, I need to figure out a way of kind of organizing that and do it in a way that's interesting and it's of value, long-lasting, not just me ranting and rambling, you know. All right, that's it. Thanks for hanging out. Take care, guys, and you know where to find me if you want to ask anything, say anything, suggest anything, and all that sort of thing. Thanks a lot. Take care. Have a good one. Bye-bye.